I think. Does it? Now it should work. Does it work? Yeah? Okay, great. Welcome. I'll give a short overview of my recently started project, which focuses on landslide characterization and monitoring using both fiber optics and dense nodal arrays. Now, very briefly, the motivation. Our motivation, or the goal of our project, is to develop and apply new seismic methods to both characterize and monitor unstable slopes over time, such as landslide bodies, rockfalls, and everything that's in between. Now, we have further specified our targets in kind of two key questions of the project so far, which is first, how to maximize the value of dense nodal arrays to characterize the structure of such large landslide bodies, and secondly, to see how we can employ fiber optic techniques such as distributed acoustic and restraint sensing to monitor landslide characteristics and dynamics over time. And to investigate this, we have chosen an experimental test site somewhere in central Switzerland, close to the Gotthard Pass, which is called the Quonda V landslide, which is a large-scale landslide, roughly over here, which I marked with the box, of around 1.5 by 1.5 kilometers. And if you look at the satellite image, you, for example, see already the tension cracks up here in the north accommodating for the landslide displacement throughout the year. And over the past 20, 30 years, this landslide has already been monitored by, for example, many GPS measurements, which provided this map where the darker colors indicate higher displacement. So, for example, here in the center of the landslide body, it goes up to around 20, 30 centimeters of displacement per year. And the great thing of this test site, as I said, is that it's already heavily instrumented with, for example, GPS and also drone-based studies, so that our data, our seismic data, we can compare it with already existing data. Now, very briefly, the setup of our project. So actually in 3 weeks, our first main field campaign will start. So I'm writing a lot of emails these days to also work out all those logistics, because in June, July, we'll deploy the big nodal array on this landslide and we'll install the first stretchers of fiber optics as well. To then in September, October 22, kind of take the lessons from this first field campaign and extend the fiber optic coverage. To then in spring 23, do the main fiber optic acquisition phase, where during the snow melt season, where from previous data we know that the highest activity will take place in that period. Now, in terms of instrumentation and targets, there are kind of three categories, where first, as I said, we'll deploy a large nodal array of around 1,000 autonomous one-component nodes next month, which will record seismic data for a month. And our primary objectives there are to construct a tomographic model of this landslide body with both active shots and ambient noise surface wave tomography. And secondly, see if we can localize the microseismic sources or the tremor-ish signal originating from the internal landslide dynamics. And additionally, as I said, we'll deploy fiber optics as well, where we have access to 6 kilometers of DAS cable, hopefully for the coming years, so we'll deploy them for a few years. And in some way, the objectives are similar to the nodal array. However, there's a big difference that the nodes will be primarily sensitive to the